It is your favorite online tutor, PDSA Tutor. Welcome to our page and make sure that you subscribe and you follow us, share as well. Here is a question coming from more concept, specifically from calculations from chemical equations. The question reads, ammonia is manufactured by the Haber process, which involves the reaction of nitrogen with the hydrogen. The equation has been given for you as you can see it there. Now, calculate the number of moles of ammonia produced when 14 grams of nitrogen gas reacts completely with the hydrogen. B. Determine the mass of hydrogen gas needed to completely react with say 28 grams of ammonia gas. Shall we? All right, good. So to answer question 1, the moles of what? Ammonia, because this is ammonia here. So for us to know the moles of ammonia, well, we can use Molar ratio because 14 grams of nitrogen has been given. So nitrogen here is 14 grams. So step 1 is, if we know the number of moles of nitrogen, we can further find the number of moles of ammonia. Let's say, so step 1, we find the moles of nitrogen. So nitrogen moles. So for nitrogen is equal to be the mass of nitrogen over the molar mass, mm, of nitrogen. So mass of nitrogen given here is just 14 grams over. We need to know that nitrogen on the periodic table is 14, but nitrogen occurs as a diatomic molecule. Nitrogen occurs like this. I think the formula itself is giving you Na2. That means that 14 should be multiplied by 2, which will give us 28. And so take note, divide another one into there, this will give us 0.5 moles. These are the moles of nitrogen, but the question tells us to find the moles of ammonia. All right, so how do we find the moles of ammonia now? So we use Molar ratio. Next, so step 1 is gone. Step 2, we will use Molar ratio. I'll write for you. So we have nitrogen number of moles there, and you have ammonia number of moles there. So the ratio, step 1 is the ratio. Nitrogen, the number in front is just 1. For ammonia, the number in front is 2. So the ratio is 1 to 2. Next is, what is the number of moles that we found for nitrogen? We found 0.5 and there X. So the number of moles for ammonia will be equal to 2 times 0.5, which is just 1 more. Can you fail? B. Determine the mass of hydrogen gas needed. The mass of this friend of ours there. There are two ways. There are two ways we can do that. So I'll show you both methods. Method 1 is what to call mass to mass ratio. Okay? Mass to mass what? Ratio. That's the first method. So let's look at the mass of nitrogen and the mass of hydrogen. So the mass of nitrogen given here is 14 grams. But for hydrogen, we don't know. But what other masses can we compare? We can also compare their molar mass. So let's go back. From the equation, nitrogen is 2 times 14 here, which is 28. So I'll put 28 there, grams. What about for hydrogen? Let's go to the periodic table. Hydrogen is 1. 1 times 2, 2. Times 3, 6. Is it making sense? So I'll go there again. The mass number of hydrogen on the periodic table is 1. Are we there? But how many are they? There are 2. So 2 times 1, we get 2. But there's also another 3 in front here, multiplying them to give us 6. So we have 6 here. Then we cross multiply. All right. All what we are doing here is a very, very, very simple ratio. All what we need to do is just multiply 14 and 14 and what? 14 and 6. So we get 28. X is equal to 14 multiplied by 6. So over 28 over 28. So X is equal to, so 14 we multiply by 6. Then we divide by 28. I'm getting 3 grams of what? Hydrogen. That's all. Method 2 is what to call mole ratio. The one I showed you, mole to mole ratio at first. So all what we are comparing is are the moles of nitrogen to the moles of what? Hydrogen. So the ratio, first of all, let's go to the ratio. Nitrogen is 1, hydrogen is 3. So 1 to 3. Walemba. 1, 2, 3. Let's go for the number of moles of nitrogen that we found, 0.5. So we put 0.5 there. Here we don't know. So basically we end up having 1.5, right? Like 0.5 times 3. That's like X is equal to 1.5. These are the moles of hydrogen. But we need the mass. Remember that number of moles is equal to mass over molar mass. And in our case, the mass we don't know, so but the number of moles we have and the molar mass we have. So we are saying mass is equal to number of moles is 1.5 multiplied by the molar mass for hydrogen is what? Let's go back. Now, when you're using mole to mole ratio, you ignore the 3 in front. The number in front is ignored. You only consider the element itself in its natural state without the numbers in front. Because do you know why? That 3, you've already used it here. So if you repeat it, you are making a mistake. So just consider how many are there here. There are 2. The mass number is 1. That will still give us 2. So you put a 2 there. What is 1.5 times 2? That will still give us 3 grams of hydrogen. So you see that either way you are finding your answer. And I'm glad that you did. Well, subscribe, like I've said. You can also enroll for our online classes. Really affordable and simple to understand. The same way you've understood this one, isn't it?